folks, sorry I am not in class today. I had a prior engagement that I had to attend to. But I don't want you to get behind it all, so we are actually going to do today's lesson totally flipped, except not flipped because you're watching it in the classroom. So, I hope you have the sheet. If not, get it from the sub. Our flipped lesson is on parallel and perpendicular lines. Now, before we get into me blah, blah, blahing at you, what I would like you to do is take a look at this sheet. Again, we're looking at parallel and perpendicular, so I want you to take a couple minutes. I want you to go on Google. I want you to go on your textbook, right, and use the glossary. I want you to look up what parallel lines are and write the definition here, okay, and what perpendicular lines are and write the definition here. In addition to that, I want you to be thinking, as you're reading those definitions, not just how is this applied to lines, but how could it be applied to linear equations, okay? We're going to fill out this chunk together in just a minute. But I do want you to kind of preview it by looking up the definition, okay? So seriously, pause this video, take this sheet, and I want you to go look up stuff online, spend 5 minutes, 10 minutes, getting some good definitions and write those in, okay? All right, now that I can assume you've refreshed your memory about what parallel lines are a little bit, let's talk about them a little bit. We'll write how they're applied to linear equations, not just lines in general. And then we're going to look at how do we actually find the equation for a line that would be parallel to another line and through a given point. So parallel lines, I'm sure you found somewhere that they're lines that don't cross, okay? So for example, you could think of a line like this. A parallel line is going to be increasing at the same rate, okay? And they're never going to hit each other. Even if we continue them on forever, at no point are they going to cross. Now, something special about this, as it is applied to linear equations, hint, hint, okay, is that these two lines, if we were to graph them on a coordinate grid, are going to have identical rates of change, okay? Which you kind of knew, right? They have to be increasing at the same rate or decreasing at the same rate. If one's decreasing steeper than the other, then they're clearly going to hit at some point, okay? Even if you don't notice it initially. Say this one's decreasing a little bit less. Even though we don't see them hit now, we know it's going to happen, okay? Here, if they have the same rate of increase or decrease, they're never going to cross. And how we apply this to equations, and it's going to blow your mind. Are you ready? If they are parallel and they have the same rate, they have the same exact slope. Who knew? Okay? Parallel lines that never cross have the same rate, therefore they have the same slope. So in the equations, it's actually kind of nice. You can tell two things are parallel automatically if they have the exact same slope. It's that easy. You look at two equations, you look at your m values, they're equivalent, they're parallel. You don't really have to do much more thinking than that, as long as you know this piece, okay? So now that we know it, let's do some practice with it, okay? You're going to be asked questions like, what is the line that is parallel to, and then they're going to give you an equation and a point, okay? So let's see, let's do a line that is parallel to y equals 2x plus 3 and goes through the point 5, 3. All right, actually I'm going to change that. Sorry, I know you hate when we're taking notes and I change things. Let's do 5, 4. That way we're not having any repeat digits. Okay, we're dealing with a 5, 4, 3, and a 2. So, like when we write any equation, okay, if we weren't given this and we were given 2 points and I asked you to find the equation, first thing that pops in your head is I need to find slope. Second thing that should pop into your head, aside from finding slope, should be finding the b value, which is your y-intercept. So here, I'm still thinking what's my m and what's my b, okay? Now, I don't need to do slope formula here at all. My slope is very, very obvious because, again, it's parallel, and if the lines are parallel, they have the same slope. So my slope of a line parallel to this means I just take that slope and I steal it. It has to be the same rate of change or they're going to cross, so I just take it. I don't have to do a formula, just borrow it. The dilemma is, and it's not really a dilemma because you know how to do this, so this isn't more work, it's actually just new work, okay? We know the slope, we know a point, we don't know our b. We do not take that b, that does not matter, okay? What we're going to do now to find our b value is we're going to plug in our m. So I have y equals 2x plus b. I need to find my b. Hopefully you all are like, plug in the point. That's true. We're going to take this, plug in 5 for x and 4 for y. It's exactly what we've been doing, okay? It's exactly like finding the equation from 2 points, except because it's parallel, we already know our slope. It's easier. So now I'm going to plug in 5 for x, 4 for y. So I'll have 4 equals 2 times 5 plus b. I multiply those. 4 equals 10 plus b. Subtract 10 to get my b alone. I get negative 6 equals b, and that's it, negative 6. Okay? This is not new. We've been doing this. So now let's think about this. Let's write our equation. They want the line. So they want it y equals, instead of m, I'm going to plug in 2x. Instead of plus b, I'm going to put minus 6. And this is the equation of the line that goes through this point and is parallel to this line. All right, so let's look at another example of calculating an equation to a line that is parallel to another, given us a little bit of information, okay? I see my line has to be parallel to this line, and it has to go through this point right here. A little bit harder because this time our slope value is a fraction, okay? It's not going to be an integer like it was before. And I also have one value that's negative in my point. So I'm going to be dealing with negatives, I'm going to be dealing with fractions. We can do it. You guys are smart. Okay. I know you don't like it, but you can do it. So let's take a look. Parallel. I say that. I hear that. I think, not just lines that don't cross anymore, I think same slope. So as I'm writing out the stuff for my equation, I'm putting the same slope. So my slope is going to be 1/2. Okay? My b value is not 4. This does not matter. I need my b. I need to do more work. I can't just look at it and know everything. Okay? So I'm going to take my slope-intercept form. Okay? Y equals mx plus b. I'm going to plug in my new m, which happens to be the same as the old one. X plus b. I don't know b. I need it. I'm going to plug in an x. I'm going to plug in a y. So I have 1 equals 1/2 times negative 3 plus b. Now, we have done a couple of these together. You need to be able to do them consistently, okay? I see a fraction times a whole number. You should know I need to change them both to a fraction. So I'm going to put this negative 3 over 1. Then to multiply them, I go across the top and across the bottom. Hopefully you're finishing my sentence. 1 times negative 3 is negative 3. 2 times 1 is 2 plus b. And over here I still have an equal 1. Now at this point I'm going to move my fraction over. It's negative, so to cancel it out, I'm going to add 3/2 to each side. Now at this point I could find a common denominator. My denominator here is 2, so I could make this whole number, this 1, into 2s, or halves. I would have 2 halves to be a whole. I add my numerators, I get 5 over 2. Now if you think of graphing, okay, if you run into a situation where you have a fraction for a b, you don't really want to graph a y-intercept that's a fraction. It's a lot easier to graph a y-intercept that is a decimal. Slope makes sense to be a fraction. It's rise over run, it's up and then over, or down and then over, or up and then backwards. You know all the patterns, okay? This makes sense to be a fraction, but our b value doesn't always. So I would take 5 over 2. I would also take 5 divided by 2, which is 2.5. So now my equation is y equals 1/2 x, right? I just kept that 1/2. And then this is a positive number, so it is plus 2.5. And this is the equation that's parallel to that, but will go through this point if I were to graph it. Next, we're going to look at perpendicular. Okay, so make sure you're recording your stuff in the right area. We're going to talk about how it applies to equations, and we'll do a couple examples together. All right, hopefully you looked up your perpendicular stuff already, and you found the definition to it. Now, I know this might not be as familiar as parallel lines. Parallel lines, we've learned about ever since we were little, okay? Perpendicular are two lines. They do hit each other, okay? But they hit each other at exactly 90 degrees. So it's a line and another line that intersect to make exactly 90, okay? Could look like that, could look like this. Either way, they intersect to equal exactly 90 degrees. Now, something that intersects at exactly that has very interesting relationship when it comes to its linear equation. Again, because we're talking about the rate of change, one rate is kind of like the opposite of the other. That is related to our slope again. So our big idea here with the equations themselves is how are these two slopes related? Well, clearly they're not the same. Okay? What they are, the slopes are opposite reciprocals. Okay? Opposite reciprocals. What that means is opposite, if it's positive, it's negative. If it was negative, it becomes positive. Okay? That's how we define opposites. And then reciprocals, you guys should know this. This is fraction stuff, right? Reciprocal means you flipped it. If it was 2/3, it's 3/2. So that means if one line has an m value that is 1/2, the other line, if it is perpendicular, should have a flipped and a switched slope. We switch the sign, we flip our fraction. So this would be 2/1, but because this is positive, it also has to be negative 2/1, okay? Which could be simplified to 2. So how it relates to an equation, the slopes of perpendicular lines are opposite reciprocals. So you look at one, you know it's perpendicular. If you take that slope, you flip it, and you switch the sign. If it's what it is when you flip and switch it, then you know they have to intersect at exactly 90 degrees. And this comes in real handy when you are doing stuff in geometry next year. Okay, you guys do stuff with parallel lines. You do items with perpendicular lines. I'm setting you up, okay? This actually is one of your standards next year. This isn't a standard this year, but it ties in nicely to writing equations. So I figured if you know it now, you're going to know it next year. Or at least once you do it once or twice, you're going to be like, oh yeah, we did this in Algebra 1. And I'm going to be like, yeah, I'm awesome. Because you're awesome and you're going to make me look good. So, know this, okay? Perpendicular. All right, now that we know what they are, let's do our 2 examples. We're going to do 2 just like we did last time, but it's a little bit more work, okay? The question you would be asked is something like, what is the line that is perpendicular? I'm not going to write that whole thing, okay? But what is the line that is perpendicular to, and let's choose y equals negative 4x plus 5, and goes through the point negative 8, 5. Okay. Hopefully this one turns out kind of nice. I want our first one to not have as many fractions in it, but it's going to feel kind of nasty at first. So bear with me. With parallel, we see parallel, we're like, sweet, same slopes, you know, they never cross. Our m is very easy. Here, if we were to do parallel, we'd write our m as negative 4. However, our relationship here is not that the slopes are the same. It's that they're opposite reciprocals. So, I start off with the opposite. This is negative. The opposite of negative is positive, so my slope's going to be positive. Next, I have to do the reciprocal. This is a whole number, but it could be written as a fraction, right? Any whole number can be written over 1. Reciprocal of that, 1/4. So, the opposite reciprocal to negative 4 is positive 1/4. This is going to be the slope of the line that's perpendicular to that. Okay? Again, we didn't have to do a formula. You just need to memorize the rule and the relationship between perpendicular slopes. This now, plus 5 doesn't matter, just like it didn't when we were doing parallel. What I'm going to do now, to find my b, I'm going to plug in my m, I'm going to plug in an x and a y, right? And I'm going to get out my new b value. So I have y equals not negative 4. Remember, I flipped and switched. I got 1/4. Times x plus b. I'm going to plug in my y, which is 5, equals 1/4 times negative 8 plus b. Again, we're in another one where we are handling fractions, but you're lucky this one's going to turn out nice. You should know multiplying. I put my 8/1. I go across the top and across the bottom. So, 1 times negative 8 is negative 8. 4 times 1 is 4. Plus b equals 5. Negative 8 over 4 is like negative 8 divided by 4. Hence, this actually being negative 2. I just did negative 8 divided by 4. Okay? So, to get my b alone now, super easy. I'm going to add 2, and I get that 7 equals b. So right here, this b is going to be a positive 7. Okay? I take these two chunks. Again, I want the line, so I'm plugging it into my y equals mx plus b. Y equals 1/4 x. This is a positive 7, so I put plus 7. Recap of our steps. The problem to this in parallel looks very similar, so I need to make sure I read my vocabulary carefully. It says perpendicular. When I see that, I think flip my slope and switch my sign. So here, my slope is -4. I knew it's going to be positive. 4 can be written over 1, boop, 1/4. Plug that in, plug in an x, plug in an x here. Plug in the y, solve for b, right there. All the same work we've been doing, just adding one little extra thought process to it. Perpendicular, parallel. I'm going to put up one more, okay? And I encourage you in any of these flipped lessons, when I put up a problem and you feel like you kind of get it, pause the video. Even if you don't want it in your notes, put it on scrap. Try to solve it. And then if you can, when you watch the video, you're like, sweet, I already know this. I'm super smart, okay? But I really want to encourage you. The reason why videos are nice, you can rewind it and get something you missed, but you also can pause it and try it on your own and then know if you did it right or not, because I'm going to go over it, okay? So I'll put one more up and then you're actually done. Awesome, you rock. Okay, not yet, one more. All right, last problem. Again, directions, line that is perpendicular, so we're still working in this section, to y equals x plus 5, and goes through the point 3, 2, okay? So, always thinking, find my m, find my b. Find my m is first. Perpendicular, flip and switch. I'm going to, or switch and flip, whatever. I'm going to notice that my slope here, although it appears invisible, right, we know it is really 1. So, it's opposite reciprocal, it's opposite, it's positive 1, so I know it's going to be a negative. And then 1, if I flip it, right, switch and flip, it's still going to be 1, okay? It's 1/1, I put this one up there, I put that one down there, it's still going to be 1. But instead of being positive, it's negative, and I actually did flip that, right, 1/1, same difference. Next, I have to find my b value. Looking over here, I have to use this as my x and my y. I'm going to plug in my m and find out my b. So, I'm going to start with y equals, m is -1x plus b. Y is actually 2. X is actually 3. 1 times 3, excuse me, -1 times 3, is -3 plus b equals this 2. That didn't change. I'm going to add 3, and I get 5 equals b, so I write it here. Again, it's positive, so I'm going to have that as a plus afterwards. In slope-intercept form, this is y equals -1x plus 5. Okay. Quick recap of our steps for perpendicular. I always need my m, I always need my b. To find my m, I look at the equation they gave me, I flip and switch, make it negative or positive, and find the reciprocal. Plug in my slope, plug in a point, find my b, plug in my m and b, and I'm done. Okay? Hopefully, this is feeling okay to you. We're going to be practicing this next time we're together on Tuesday. Okay? My tentative plan right now, to be honest with you, is to do a quiz on Wednesday of next week. So when we get together on Tuesday, we'll go over this. I'll let you know what items are going to be on the quiz. I can tell you right now that we are going to involve writing equations from tables, writing equations that are linear from 2 points. That will be on there. Rearranging into point-slope form, into slope-intercept form, and into standard form. Okay, that standard about rearranging to highlight specific variables for specific purposes is going to be on there. Okay, so if you have extra time this weekend, I'm not necessarily assigning homework, but what I would like for you to do is to take a look over those 3 forms. Okay, we did that on Wednesday. Okay, look over those notes. Try to do a couple on your own if you want to. Okay, you did have homework that was on that topic due today. Hopefully you've passed that in. If you haven't, please finish it and pass it in. Okay. Again, any questions? You guys know I'm here early, I'm here late. I won't see you till Tuesday, so you can come see me on Monday if you're having an issue with this, or even with changing things into different forms. Okay? All right, thank you. Be good to the sub, be nice, be kind. I'll see you later. Bye.